Hello, everyone. We should be up and streaming now. Welcome to an introduction to agent-based modeling, week 11. All the units. Yeah, that's right, because now we have them all up online. They're all available. You can do everything now. And hopefully everyone got their final projects in. So the way this works is there's this week, next week, and one more week after that left in the course. This week and next week, you should be finishing up your peer reviews, getting those in. And then the final week of the course is left over for any cleanup of tests or anything like that that you've left behind, right? After that, as a reminder, again, all the materials will still be available up online. They're only not available when the course is in session, right? So next summer, if the course is back in session, then they won't be available. The only thing that will go missing is the forums. Unfortunately, just because of the way the forum system works, there's no way to preserve the forums for a future, right? If you see anything in the forums you really want to save off or anything like that, you can grab it as a document. Some people have shared those documents up online at times in the past for other sessions, okay? So big news, you're working on unit 9 is the newest unit to go up. And the reason why unit 9 goes up is unit 9 is kind of advanced ABM, things that you can't really do with what we've necessarily taught in this course, but things that might be useful for you to start thinking about how to move towards, right? Theoretically, maybe you might even be able to do it with what we've done in this course, but some of it's advanced techniques, advanced methods, right? So take a look at that. Let me know if you have any questions or concerns. As always, if you have a question for me, you can tweet at me at Intro to ABM. You can also post the question in YouTube. And I will also be doing 2 more of these office hours next week and the week after. And during those, you can always send me an email ahead of time, post in the forums ahead of time. Chaddock has been doing a great job of getting those forum posts and those emails together for me to take a look at. So if you plan to email or if you plan to post on YouTube or tweet at me, please do it early on in the office hour just so I can make sure I see it before I sign off. Okay. So let me see what the questions are we got today. So yeah, one general announcement I want to make, and this came up a couple of times, is some people had some troubles at the very last minute uploading their models because they had some attachment that was not recognized, right? Unfortunately, the way we have it set up is the submission system will only accept .n logo files, I usually make an announcement about this ahead of time, but no one had asked that question yet, so I kind of forgot to make that announcement. So as a result, there were some complications with getting some of the files up. If you had a problem along those lines where you couldn't get an attachment to upload or something like that, please reach out to us at abm@complexitexplorer.org. And we'll take a look and see what we can do to get that issue resolved. Otherwise, hopefully most of you were able to get your files uploaded. If you had any additional concerns or problems, please email abm@complexitexplorer.org, especially if it's specifically related to your model. If it's related to the Complexity Explorer website, then you can probably skip the step of emailing me and just emailing admin@complexitexplorer.org. And they should be able to help you out. So it's either ABM or admin, ADMIN, @complexitexplorer.org, depending upon your problems. Okay, so that came up a couple of times. And that's generally true. So there were some issues with GIS around those levels. There were some additional data files. There were also, yeah, let's just leave it at that. Another interesting question that came in over email is if we would be teaching a more advanced version of this course, for instance, stressing NetLogo 3D and GIS extensions in more depth, or if we have any recommendations on this. Well, my general recommendation is to take a look at the textbook, right? There is definitely, at times, more detail on some of these subjects, right, than others, right? This course is meant to be as a complement, but not substitute for the textbook, right? So take a look there. That's definitely a good place to look at. There is a possibility that a more advanced version of this course would be created at some point. I don't see that happening in less than a year at least. But we can always talk about it. It takes a lot of effort to develop these courses, and right now this one is based off of a workshop I have been teaching for about 10 years. Actually longer than that. Wow, it's been too long. So to get a new advanced one up and running might take even a bit longer than that. Okay. But so I would recommend looking at the textbooks at this point. There is a little bit of confusion just on a technical detail about the end of the course. So apparently the FAQ page says that the course ends on October 1st, but the actual course description says October 10th. The correct answer is October 10th. In fact, I may be able to change this right now. Let me see if I can get in there. Sometimes I can change these things easily, and sometimes I have to oh, it looks like I can. I'll change it right now. So it'll say October 10th too. Okay, there it goes. So now both the FAQ and the course description should say October 10th as the end date for the course. Okay. So a couple questions came in from the forums. One from Pankaj and Myra, who asked, there was a discussion so in the section where we talk about models as communication, how to communicate the models, and Pankaj in particular really wanted to emphasize that clearly communicating your model is almost 100 times more important than the model, and I definitely agree with that, right? So I've tried to emphasize again and again that documentation and the information tab are extremely important in the modeling process, right? A model is not just the code you write. The code by itself is useless, right? How do I tie the code to the world? I can't, right? I need a translational entity, such as documentation, that takes that code and translates that code to something that tells me something about the world, and hopefully, illuminates the big T truth about the world, right? That's interesting to explore. And the model by itself, the implemented model by itself, does none of that, right? If you think about it, I can write the equation and this is true for all models, not agent-based models. If I write the equation F equals ma, right, that tells me nothing about the world by itself. It's only once I understand that force equals mass times acceleration that model impacts to, and what that means, right, that it becomes a useful piece of truth about the world, right? So documentation and communication about your models is very, very important. And you need to, and I tell this to my, and this is not something that you might think that oh, I don't need to explain this, people will just understand this. It's not true ever, right? I would say the #1 comment, even when I'm writing papers published in the top journals in my field, that I get back is this isn't explained well enough. In fact, I'm working on a revision right now for a journal paper, right, where I'm having to write an additional 10 to 20 page appendix just to explain some of the concepts that are in that paper, right? And that appendix will be available online afterwards, right, after the paper is published. But my point is that no matter how crystal clear you think your explanations are, you can spend the extra time to make them that much more crystal clear. Never assume that, especially in an interdisciplinary class like this one, where we're teaching a method, right, rather than a particular domain, that your audience knows the subject matter that you're talking about, right? So it is very, very clear to make it as extremely clear as possible what you're going on about, right? I think it's very important to communicate your model extremely well, and I like Pankaj's comment here that communicating our model is 100 times more important than the model itself. That is very true, right? Formulating and describing your model succinctly is much more important than the actual code itself, right? In fact, I used to say what Pankaj is doing a little bit differently. I would say the process of designing your model, right, which involves documenting exactly what the model is doing, is more important than the model itself. right? That even the mere fact that you wrote it down, right, is more useful, right? Because then people can start to understand what the model would have looked like, even if they can't see the results, right? Now, occasionally the results themselves are spectacular and really interesting, in addition. But communications of models and making sure that your model is that your documentation is unambiguous as possible is very, very important. So thank you very much for those comments. Okay. So we had another question from Nawin. And essentially, the question boils down to they're using this import pcolors RGB, which import pcolors RGB basically reads in a file and then sets the background colors to match that file. And so you can basically use that to set up a world, right? And so in his particular case, he was importing a graphic file, right? And he was assigning colors to the various spaces, right? And he was using those colors to basically establish walls in the world, right? And then he could make and the nice thing is then you can make the agents appear in the spots that weren't walls, right? And so you can do that once you've imported the colors, right? Then you can have the agents only appear in places where the walls aren't, where the patches aren't walls, right? And Chatica has one way to do that. So let's I don't have a file set up to do this right now, but we can skip the part. I think there's two questions here, right? One is about just like importing a background world, right? And the other one is about how to make agents interact with walls in that background color world, right? And one of the questions that Nawin has is this the only way to pull in a world from the outside world? Well, it's not. There is one other way. You can also import GIS data as well as importing the RGB. Those are very similar. But yes, essentially, if you want agents to interact with stationary objects, really the best way to do that is to have the stationary objects be patches and to have the agents be available other than that, right? So I guess the question is yes and no. Yes, there are other methods to bring in patch colors and bring in substitute patches. But yes, probably the best way to get agents to interact with walls in a space is to have patches be different colors and have the agents detect when the colors of the patches aren't the right. There is one other way, and I'll briefly mention it, right? So agents can obviously interact with other agents as well, right? So you could have agents that were different shapes and sizes and have turtles interact with those agents. The problem with that is the agents really aren't different shapes and sizes. Even though we represent them as different shapes and sizes, in that logo, the agents actually take up a point, right? They're at the center of that shape. And so when I tell an agent to I can tell an agent to move away from another agent. I can tell an agent, which we did in Heroes and Cowards, right? And I can tell an agent to move in the direction of another agent, right? But it's really hard to say don't run into this agent because the agent is essentially a point, and 2 points can pass right by each other, right? So in reality, even though you could do it, right? So you could do something like not allow one agent to move within a radius of one of another agent, right? That would be a tricky piece of code, but you could do it. It's usually not as successful as using patches, right? Because patches have a definite two-dimensional shape to them. They aren't single-dimensional points. Okay. So let me see if I can get this. So let's first of all, no, that's not the right one, obviously. Okay. First of all, let's talk about how we do image imports. So this is the image import code snippet, which is in the NetLogo models library, right? And so I can import a patch colors directly from a file. So in this particular case, I have a 401 by 401 wide world, right? And each of these individual patches, right, are colored based upon an image I brought in. In this case, it's an image of the world itself, right? And so let's say, and this is importing into the patch colors framework, right? So let's say that in this particular case, and I can do other ones, right? So this is the world, this is dandelions. Oh, I imported the one on top of the other, right? So here's the dandelions, right? And so if you go and you look at the actual code, and this is an interesting one because the code is actually in the code itself. So all it runs is import pcolors file name, right? And where file name is this file. So it's very simple code, right? So now let's say, so that's how you import colors into the patches, right? And often this means you have to make the world really big in order to get any resolution at all, right? So if I were to, let's see, if I were to set the world size to 100 by 100, right? And now import it, wait, sorry, set the world size, let's see, I'll do 100 by 100, and then I'll do the patch size of 2. Right, you can see it looks a lot blockier. Well, you might not be able to see because you're looking at it over YouTube. Let me do it this way. Let's do it. Let's go really small. So let's do it 10 by 10, 21 by 21, right? And then we'll set the patch size to 5. Nope, actually that's still not big enough. Patch size to 10, right? You see, now you can see that if I have a small world, so in this case the world is only 21 by 21, right, the picture, it's not going to really look like the picture, right, because it's having to average, just having to kind of spread many pixels over one pixel in one patch, right? Whereas if I do the original, which was 200 by 200, right, oh, and now I got the patch size too big. Right, so now it looks nice. So the big point I want to show you here is that it is possible to bring in patches, right, that have these different colors. Now, when you do this, right, all the patches, they're going to be as close to the color as possible, which means they're probably not going to be right on. So in this case, the P color is 11.3, for instance, right, at the center of this patch, right? And so, oh, sorry, you guys can't see the patch inspector. I hate it when it does that. It's because this way that I use the software. So let me add in let's see. Actually, I think I've tried this before, and you can never see the patch inspectors because the way the system works. Okay, so let me instead do this. So let's just do show P color of patch 18 negative 19. Right. So this is the patch I was inspecting. It's, as you can see, 11.3 is this patch color. That's going to make it tricky to say, like, hey, I want agents to only appear on patches that are yellow, right? Because actually there's many, many shades of yellow, right? So if instead what I do, so let me see, that one's actually not even close to yellow. So let's look at this one. 58 to negative 47, right? So this is 44.6. That's pretty close to right in the middle of yellow. And you can check that if you want by going up to Tools, Color Swatches, right? And let's see, can I make you see that? Yeah. So as you can see, right in the middle of yellow is 45. So let's say that I want turtles to only appear on patches that are like in the middle of this range, right? Where it says like, let's say 42 to 48, right? Okay. So then what I can do is write a piece of code. So there are no patches in this one, so that makes it easy. So what I can do is to set up, create 100 turtles, right? So what I saw that what Chadwick had done was he had basically written while patch color is less than 43 or patch color is greater than 48 or 42 and 48. So then right random 90, left random 90, forward random 10. Right, so what this is going to do is just going to make the turtles bop about the room or world until they find a yellow patch, and then they'll appear on that yellow patch. This is a standard way if you want the patches to only move, if you want turtles to only appear on yellow patches. Oh, and I forgot brackets. Said the discussion last week too. Okay. So what I can do, right? Set up and see, they're going to be really hard to see because their size is so big. They're so small. Set size 5. Oh, you still can't see it. Let's set color black. Let's see if that helps. I forgot to put a clear all at the beginning. Actually, we don't want to put a clear all. We just want to do ask patches. Ask turtles die. If we did a clear all, it would remove the background. We don't want to do that. So now you can see maybe a couple of black spots that showed up. Oh, you know what I did? I had them appear at the center of the world, which means that they're in the center of the world happens to be yellow, so they're all going to be fine. So what we want to do before that is set XY random X core random Y core. Okay. So now you'll see that there's a couple. Oh wow, they're really small still, even at size 5. Make them a little bigger. There you go. So now you probably can see a couple of them. And you'll see, like, if you run setup, you'll see them jitter a little bit first. That's because they're moving around the world trying to find a yellow square. Now, let's say that now that I have them on yellow squares, I want them not to leave yellow squares, right? Well, then, the way we do that is very simple. It's very similar to what we're doing. What we can do is we can say, ask turtles, if patch ahead, if P color of patch ahead, and patch ahead is the patch that they're currently facing. Yeah, actually, probably the easiest way to do it is say let new patch be P color of patch ahead. The color new patch it's called. If color new patch is less than 42 or color new patch is greater than 48. Oh, so if that's true, right, if it's one of those, then we don't want them to do, actually let's do an if else. Then we don't want them to do anything. But if it is a yellow patch, we want them to just go forward one. If it's not in that color range, right, so it's something other than yellow, then let's do a random turn. Okay? So this will keep them from ever moving off of the yellow. No, patch ahead 1. So patch ahead takes units, and you want it to be 1. So that's the third step in random. Right? So now we can set up, and now we can go, repeat 1,000, go. Right, and you can see they always stay on the yellow. Right, so that's essentially the way you create walls in Netlego. Now I did it by keeping them on the yellow squares. Alternatively, if you had like a world that was all different colors except for black walls, you could just check to see if the patch ahead was black. right? And that would be essentially equivalent to. So that's how you work with patches and walls in NetLogo, and hopefully that was helpful to help you understand now when how to do this. Okay. So Myra asked, "Hello, Bill. I would like there to be a second course to improve and deepen areas of opportunities. Thanks. I had a pleasant experience." Great, Myra. I will definitely work on it. It's something that has been asked. One possibility is we do something that's a little more freeform, right? That would be the one thing we could get up to speed quickly. But I also need to talk with everyone at the Santa Fe Institute, the Flux Explorer group, talk about that with them as well. This is definitely a major undertaking, so it's not my sole decision. So it's good to hear there's some interest in doing an advanced course thing for sure. Like I said, as I remember, so I recommend definitely check out the textbook. It's a great way to get some additional comments. Okay. So also a question, Mohammed says he wanted to know if we could access the variables in the code tab of the System Dynamics Modeler. Yeah, that's definitely possible. Essentially, the System Dynamics Modeler is running a version of NetLogo code, right? So you can access it. So let's show that off real quick. So let's go back to the window, to the NetLogo window. Okay. Learn the models library. Let's go to changes here. Let me pull up the System Dynamics model. That's easy to understand. Just because I don't want to spend all our time just understanding it. Okay, we'll just pull up the logistic growth model. That's very simple. So let me get this so it fits back on the screen a little better. Okay. And let me add in the System Dynamics window as well so you can see that. Okay, so now you should be able to see both windows. Nope, don't want to do that. Turn off my camera. Right, so there you go. So now you got the System Dynamics Modeler. And what Mom is specifically asking about is that if you look, there is a code tab on the System Dynamics Modeler. And if you look at that code, right, there's all these variables there that that he wants to know if you can access. And the truth is, yes, you can. In fact, let's say if I want to just do print to one of the variables stock, right? I can do that right here in the non-System Dynamics window, right? And it's just printing the value of the stock over time, right? In fact, actually, so that's a very simple example, right? There's no stock variable here, but there is over here, as you can see. No, you can't blow up. You can't. That's interesting. I'll have to email them. You can't. I can't make the text larger in the System Dynamics Modeler window. I should be able to do that. Anyways, so I can access all those variables directly in the code tab, right? And kind of go directly from there. Anyways, that's interesting. I thought I used to be able to do other stuff. Okay. So it is direct code that you can access from that format. You can even do things like change the butane. Oh, I guess you can edit this one. Yeah, you can. Okay. Sorry. The System Dynamics Modeler window has changed a little bit since the last time I looked at it, so I'm trying to make sure I understand exactly what's going on. But that allows you access. In fact, there is a model, right, that brings these two together. So one of my favorite models, and I think I've shown this off in this class before, is the wolf sheep dock model. Okay. So let's see if these load up correctly. So it looks good. Yeah, it does. Okay, good. So in this case, there is an agent-based model of wolf sheep, and then there's the dynamics model of wolf sheep, right? And when we can set up a comparison which sets them both up exactly the same, and then we can do a compare run, which basically runs them kind of at the same time and looks at them aggregating. But as you can see, both sets of data are being aggregated in this console, right? And so wolf stock and sheep stock, which are variables used in the plot, are actually variables that are being updated directly by the system dynamics model, right? So this is an example where the variables were accessed directly, right? And this is kind of a cool example because it lets you show and compare exactly between an agent-based model and a system dynamics model. For those of you who don't know much about system dynamics model, there is a video about that where I build a system dynamics model from scratch. So I highly recommend you take a look at that. Okay. But yeah, I think actually, honestly, if you were to ask me, and I think this is a good place to end for the day, I think that, combining hybrid modeling approaches, right? Modeling approaches where you take like the power of an agent-based model and combine it with a system dynamics model or combine it with a machine learning model. Those are going to be very powerful solutions for a lot of the problems we run into in the future. So I would recommend, if you're interested, take a look at some of those models and start exploring them. I think that, system dynamics models are a great way to represent a continuous system. Agent-based models are a great way to represent a discrete system. So even in things like the wolf-sheep, right? Wolf and sheep populations are pretty discrete, but something like the amount of, flora in the system that sheep can eat, like grass and leaves and stuff like that, that might be better modeled as a continuous variable, right? It's not like there's a sheep and they eat a whole leaf, right? They may eat half a leaf, right? So it's quite possible that that's a continuous variable. So you could imagine a model where the wolf and the sheep were modeled using agent-based modeling, but the leaves were the flora in the system were modeled using a system dynamics model. And I think that'd be a powerful way to combine the appropriate representations for both those systems. Okay. Well, if there's one other question Carlos wrote in and asked. There are some web and Twitter groups of ABM NetLogo users which share their experience. Which ones do you recommend to follow? Well, first of all, I definitely recommend what's called the NetLogo users group. I think I've talked about this in the videos in the past, right? So this is the official one put together by the CCL, who makes NetLogo, right? So let me bring up a window capture. So if you go to the CCL's webpage and look under resources and links, you'll see that there is a Twitter feed. So actually, the first thing is to follow the NetLogo Twitter feed, right? But then there's also a NetLogo users group on Google, and then Stack Overflow's NetLogo groups. And I highly recommend, those are probably honestly my favorite resources to follow. If you find another one that you particularly like or are interested in, let me know. Of course, another good place, two other places I always recommend are the NetLogo Modeling Commons, right? And this really isn't like a discussion forum, but it can be a discussion forum because you can basically go in and talk about other people's models, right? So you can list all the models, you can go and explore other models that are up there, and then you can comment on them. So if you go into like this one called Food Chain with 10% Energy Rule, you'll see that there's a Discuss tab, and people there will discuss it. And then this one, it looks like the original author posted a link to some other book, right? Actually, it's not the original author. Someone else posted a link. So maybe they're actually have a similar model up as well. And then finally, the other one I recommend is openabm.com. So openabm is also known as ComsysNet, is a model repository, but also has a bunch of discussions, and there is a community forum where there's discussions about agent-based modeling going on, right? So those are the places I most strongly recommend. I hope that's helpful, Carlos. Myra asks, what do you think about the causality fashion theme in agent-based modeling? I assume what you mean, Myra, and correct me if I'm wrong, is how well does an agent-based modeling show causality? Well, honestly, I gotta admit, I think the causality work that's being studied in a lot of places, right? So there's a lot of people who have a lot of emphasis on, oh, but that doesn't show a causal link, or that doesn't show a causal explanation. I personally think that that's a little overblown in general, if that's what you're asking me to comment on. I think it's really hard to make causal claims about anything, right? All we can do is hope to get closer and closer to causality, right? And so I think we can assess how helpful a causal story is. I don't know if we can assess whether something is causal or not, right? If that makes sense or not. So I do think agent-based models are essentially often, they don't have to be, but essentially often are what I would like to call, and what David Krakow at Santa Fe Institute calls a mechanistic model, right? They are models where we are describing the mechanisms that could give rise to a phenomenon we're observing, right? And as such, right, they make a stronger causal claim than other models do. Now the problem is, right, is that, and Josh Epstein talks a lot about this in some of his most recent work, is that they don't necessarily make a claim that they are the only possible causal mechanism, right? So, for instance, if I see birds flocking, and I have my 3 rules that we showed early on in the class, and those 3 rules seem to emulate the way birds flock, right? There's no way to prove that that is the only way birds could flock, right? There could be other causal mechanisms, right? And so some of the stuff Josh and I have been talking about recently is kind of how do you look at, like, so if you restrict the space of the possible rules that could generate birds flocking, how do I come up with all the possible rules that could generate birds flocking, right? And then even if I don't have a causal claim for the particular set of rules I'm proposing, I at least can say in this space of rules, there is no other set of rules that generates a phenomenon like what we're observing, right? And that seems to make an even stronger causal claim. And stay tuned on that, where there's some early discussions about having a workshop and having potentially a book along those lines discussing what we're calling inverse generational social science, right? So generational social science is I propose a theory, and from that theory, I write an agent-based model, and I show that that model generates the behavior that I observe in the world around me, right? Inverse generational social science says I identify a phenomenon in the world I want to observe, birds flocking. I lay out a space of the rules that could possibly describe how those agents could flock, and I identify all, and then I infer the agent-based model that is most likely to give rise to birds flocking, right? Or I infer all the agent-based models that are most likely to give rise to birds flocking. And so causality is hard, right? If causality was easy, then we wouldn't have millions of scientists working on problems like this all the time, right? So I honestly suggest that the way we use our models is not necessarily to make a strong claim about causality, but to argue that if we assume that the world works this way, we assume this is the chain of causation, right, then there is something that we can do better about the world, right, that changes the way we see it. Hopefully that helps. For me, it's much like the question of validation. I don't believe any model is causal or not causal. I don't believe any model is valid or not valid. All of them are kind of steps along the way of validity and steps along the way of causation. Okay. I think that's a good place to wrap up for the day. Just checking to make sure there's no other questions I had missed along the way. But I don't think there are. Thanks, everybody. As I said, I will be doing 2 more agent-based modeling office hours. So let me know if you have any additional questions. Take care. Bye.